Hey everyone, and welcome to This Explainer. Today, we're tackling what is arguably the biggest mystery in science right now, your own brain. Specifically, we're going to ask a question that might just turn your entire sense of self completely upside down. We're going to uncover who is actually driving your decisions. We all like to think we're the authors of our own stories, right? But as we're about to see through some truly mind-bending neuroscience, the truth is way more complex, and frankly, it's absolutely fascinating.
So let's start with a scenario I'm almost certain you can relate to. Have you ever made a crystal clear decision, say promising yourself, okay, I'm only watching one more episode of this show, only to do the exact opposite and stay up until 2 in the morning? You made a choice, but your body seemingly rebelled against your own mind. It really makes you wonder, if you decided to go to sleep, who or what decided to keep hitting next episode? Are you truly the one making your choices?
Okay, let's dive into this with Section 1, the illusion of control and deconstructing the I. To figure out who's actually in control, we first have to look at this whole illusion of control. Because you see, being conscious isn't just a simple on and off switch. Under certain medical circumstances, we can actually watch how different parts of our awareness become totally unsynced. Take sleepwalking, for example. The motor and visual cortexes are highly active. People can walk, eat, sometimes even drive a car. But the prefrontal cortex, which is the brain's conscious decision-making center, stays fast asleep. You're moving, but your identity isn't in control. Now, contrast this with general anesthesia. When you go under, specific drugs alter the communication between brain regions, completely shutting down the thalamus. The thalamus basically acts as the central information hub. When it shuts down, you lose all conscious experience. The whole brain is physically still there, but the crucial messages, they just aren't getting through.
Now, what's really interesting about this slide is that number, 90 billion. Your brain is made up of almost 90 billion individual neurons. And yet somehow, this unimaginably vast network works together to produce the incredibly convincing illusion that there is a single, unified person inside your skull. But ask any neuroscientist, and they'll tell you the I is not a unitary thing. It's heavily distributed across this massive piece of biological machinery.
Moving right along to Section 2, two minds, one brain. Let's step inside the split brain.
If you think having a unified self is just a given, well, wait until we look at the corpus callosum. This is a massive bundle of fibers that essentially acts as the main communication highway connecting the left and right hemispheres of your brain. Now, for some patients suffering from really severe epilepsy, surgeons will actually cut this highway to prevent seizures from spreading from one side to the other. But when this bridge is surgically severed, the two halves of the brain can no longer talk to each other. They literally become isolated entities.
So what happens when this highway is cut? Well, in a really famous experiment with a split brain patient named Joe, researchers flashed the word Texas only to his right brain. Now remember, that's the side that cannot speak. Using his left hand, which is controlled by that right brain, Joe successfully draws a cowboy hat. But here is the kicker. When asked what he drew, Joe's left, talking brain is completely confused. Because the highway was cut, the left brain never saw the word Texas. It has absolutely no idea why the hand just drew a hat. You literally have two separate mental systems operating completely independently inside one single body. It's wild.
Section 3, hidden forces shaping you, the invisible drivers. Beyond the physical structure of your brain and severed highways, there are deeply embedded invisible drivers, like raw emotions and complex social dynamics, that heavily dictate our actions, often without us even realizing it. Enter the insula. Researchers observing patients playing high-stakes investment games found that emotions like guilt act as powerful, invisible guides for our behavior. The insula acts as the brain's thermometer. It detects the ambient emotional temperature of a situation. So if you're tempted to act purely out of greed and keep all the money in a cooperative game, the insula flares up. It gives you that uneasy gut feeling of guilt, signaling, hey, maybe harming someone else isn't the best idea here.
But, reading the temperature is only half the job. That information has to go somewhere to actually be acted upon, which brings us to the brain's thermostat, the prefrontal cortex. This region takes that raw emotional temperature from the insula and integrates it to actively regulate your choices and your behavior. It literally pumps the brakes on your greedy impulses, allowing you to cooperate and make socially sound decisions.
Let's move to and see how this builds. To see how absolutely crucial this thermostat is, we just have to look at a real-world medical marvel, the famous case of Phineas Gage.
In 1848, a tragic railroad accident blasted a massive metal rod straight through his prefrontal cortex. Miraculously, he survived. Months later, his memory, language, and motor skills were perfectly intact. But years later, it became glaringly obvious that his personality, his social filter, and his morality were permanently altered. Because his emotional thermostat was destroyed, his behavior changed entirely. This proved a monumental point in neuroscience. The things that make you are physically housed in the brain's delicate structures.
But it's not just physical accidents that rewire us, right? It's our environment too. And get this, it spans across generations. Dr. Bianca Jones-Marlin did some groundbreaking work on epigenetics, where she paired the smell of almond with a mild shock in mice. As a result, those mice grew more cells in their noses specifically to detect almonds. It was a direct environmental adaptation. But here's the mind-blowing part. That genetic memory was maintained in their sperm and egg cells. Their offspring were born with those exact same increased almond receptors, even though they had never experienced the shock themselves. Environmental trauma physically rewired their genes, shaping the brains of future generations before they were even born. No way, right?
Section 4. The fragility of agency. Who is actually deciding?
So if we're influenced by our great-grandparents' trauma, our brain's hidden emotional thermostats, and 90 billion firing neurons, who is actually deciding? What happens to our fundamental sense of agency and free will? To answer that, neuroscientists ran an astonishing experiment using a TMS device. That's a magnetic field that can physically trigger a movement in a subject's finger. Sometimes the subject chose to move their finger, and sometimes the magnet moved it. But crucially, when the scientists fired the magnet at the exact millisecond the subject voluntarily chose to move their own finger, the subject's brain got completely confused. The subject actually claimed, "That wasn't me. I didn't initiate the movement, it was the computer." Even though they had deliberately chosen to move, the altered sensory feedback made them completely disown their own deliberate choice.
The takeaway here is profound. Agency is just a sense. Our feeling of being the author of our actions is just another fragile sense constructed by the brain to make meaning of the world, just like sight or smell. And just like an optical illusion can completely trick your eyes, your sense of free will and agency can be easily disrupted, manipulated, or lost completely under the right circumstances.
Which leads us to Section 5, the power of letting go, releasing the controls. Now, if all this talk of fragile agency is making you feel a bit powerless, don't worry. We're going to reconstruct this narrative right now. Because it turns out that giving up conscious control is actually the secret to unlocking peak human performance and creativity. When researchers put professional freestyle rappers inside an MRI scanner, their brains looked totally normal when they performed memorized lyrics. But when they started spontaneously improvising, just making up rhymes on the spot, the brain's prefrontal cortex, that conscious, effortful self-monitoring center we talked about earlier, intensely deactivated. The brain's conscious decision-maker literally had to shut down, step out of the room to allow true improvisation and creative flow to take over.
And you know what? This applies to physical skills too. Injecting conscious control into a deeply ingrained skill actively decreases performance. Imagine a professional basketball player shooting a high-stakes free throw for $1 million. If they suddenly start overthinking their elbow angle and grip, basically trying to use conscious control over a well-practiced, unconscious routine, their brain's flow is totally disrupted, and they're much more likely to choke. You literally have to let go of conscious self-monitoring to perform at your absolute best.
And this brilliantly illustrates the overall reality of our minds. A massive 95% of your brain's incredible, complex work, calculating movements, processing trauma, regulating emotions, digesting food, happens entirely unconsciously. Only a tiny fraction is dedicated to your conscious awareness. The unconscious you is doing the heavy lifting. But rest assured, it is still you.
Which brings us to our final question to ponder today. If your unconscious is doing most of the heavy lifting, how much of you is really calling the shots? We are wonderfully multidimensional creatures, shaped by our past, our environment, and billions of firing neurons working completely outside our awareness. By understanding that our conscious self isn't always driving the car, we can actually gain a much deeper appreciation for the magnificent, unseen engine that makes us who we are. Thanks so much for joining me on this explainer, and keep questioning the reality inside your own head.